Hi everybody! Today I'll show you how to assemble one of the most affordable desktop 3D printers that you can buy and deliver to our country. It costs around $150 and the delivery costs about $30. The package is large and weighs 10 kilograms. The box contains metal parts, acrylic parts, belts, electronics, limit switches, a control board, and an LCD monitor. The set also includes a 240-watt power adapter. Some parts have been made with another 3D printer. These acrylic parts are covered with brown paper. I recommend you remove it. Yes, it's boring and time-consuming while you can't wait to assemble everything. And some people don't peel it off because of that. But look how beautiful it is without the brown paper. Let's start the assembly. It's very much like assembling a Lego kit, but there are more elements and they are all different. Getting ahead of myself, I'd like to tell you that I liked assembling this printer so much and I was stunned by the printing outcome. Insert this nut into a special hole in this acrylic element. Tighten the nut with a screw to connect these two elements. Assemble all the remaining acrylic elements the same way. The assembled element is firm enough. Attach these corners to the upper side of the element the same way. Assemble the front part of the printer support. The whole assembling process took me 6 hours, including small breaks. This connection type is easy and stable enough. Attach the rear element of the printer support. Put 2 nuts onto these metal guide rods. Then put on 2 washers and 2 more nuts. Set these guide rods this way. Put an additional washer and a nut and tighten the nut very carefully. Mind that acrylic parts can break under pressure. Tighten all the nuts of both guide rods. It should look like this. Attach the front part of the printer support. The process is easy. You just need to be careful. Attach the Y-axis limit switch to this acrylic element. Attach the Y-axis limit switch and the acrylic element to the rear element of the printer support. Connect the Y-axis motor wires and attach the motor to the rear element of the printer support. Attach the backup plates here. Put linear bearings onto the guide rods. There should be 2 linear bearings for each guide rod. The guide rods are moving. They should be stabilized. Lower the elements a bit. Attach these backup plates to the hotbed aluminum plate. Do not fasten the screws tightly. There are special holes there already. Fasten the plate to the linear bearings with screws. Check if it moves smoothly. Make sure there is no looseness. Turn the assembled elements upside down. Set the belt by inserting its end into these clamps. Tighten the clamp screws to fasten the belt to the aluminum parts. Connect the belt to the motor and pull it upwards and then through the upper roller. Cut off the excess with plastic nippers included in the set. Tighten with a screw. It should be this tough. Assemble 2 motor cases the same way you assembled other acrylic elements. This printer has 4 identical step motors. Insert the cases into the slots here and fasten with screws. Install the Z-axis motors. These motors differ by their wire lengths only. One of them has shorter wires, while another has longer wires. The motors should be working simultaneously during printing. Attach the backup plates on the top. Connect the limit switch that will control Z-axis movement. These are the slots for it. The switch should be moving along them during calibration. Put the left Z-axis nut support onto the left Z-axis rod. Cover the axis rod with the backup plate. Attach the right Z-axis nut support the same way. Insert the threaded rods into the nut supports. Connect the threaded rods to the motor. Insert the X-axis guide rods into the nut supports and put the linear bearings onto the rods. Put 2 bearings on the upper rod and 1 bearing on the lower rod. Measure the distance between the left and right Z-axis nut supports' lower edges and your table to make sure they're evenly set. Assemble everything. It kind of looks like a 3D printer now. Attach the Y-axis motor. Connect the wires to the extruder and pull it out of its case. Attach the extruder case to the bearings. Check their movement. Attach the belt to the extruder case and the bearings. Insert the extruder into its case. Unscrew these two lower screws from the case. Assemble the cooler and the cooling fin with these two long screws that are included in the cooler box. Attach the cooler to the extruder case with screws. Install the hotbed. The hotbed will act as a platform for the printer to lay its layers on. Don't forget the springs. The platform should be springy like this. The springy motion is necessary for the calibration process. Don't forget to mount the LCD screen. It's fastened with 4 screws, 8 nuts, and 4 connectors. Connect the X-axis limit switch. All these switches will be used during the calibration process. Connect the printer power wires, the red one to the V+ plug, and the black one to the V- plug. Connect the power wires to the power adapter. The brown wire is phase, the blue wire is neutral, the yellow-green wire is ground. Assemble the electric circuit elements. The control board has a microcontroller and radiators too, so it won't overheat. Otherwise, there can be problems. Attach the main board with these plastic pillar washers. Connect all these wires from the motors and the screen to the main board using the switches. Every wire is marked. This one has a Y motor sign. The control board has the same marks. You can see the same Y motor sign here. But I didn't just watch the signs. I checked the actual connection of each wire and connected the wires only after those checks were complete. Collect all the wires into this pipe to have them both mechanically and electrically safe. I found this activity to be very calming. It should look like this, nice and neat. Start the calibration process. This motor was rotating in the wrong way. I looked at the scheme and swiped these black and green wires. The motor works correctly now. Measure the distance between the nozzle and the hotbed. Lower this supporting element by the same distance. Now, the distance between the nozzle and the hotbed should be about 0.2 millimeters, and it should be the same for every part of the hotbed surface. This is how the calibration is done. Choose Quick Settings, Home All. Then choose Disable Stepper, and now you can control the motors manually to measure the distance between the hotbed and the nozzle. See, the sheet of paper can get through, while 2 sheets of paper cannot. If you plan to use the SD card for printing, you should move all the necessary information to the card. By the way, this very card was included in the printer's instruction manual set, and there were some test prints on the card already. But I want to print something else. I want to make a whistle. Something like this one. I'll put the link for it in the description box. Turn on the printer. Wait for it to heat up. Go to the card menu and choose the necessary file. At first, I couldn't get the printer to work. It just showed preheat ABS on the screen. That meant the plastic was still heating up, but instead of 95, there should be 100. Then the number changed to 98. When I shortened the hotbed power wires, the temperature rose to 101 degrees. That's enough for printing. The printing process has started, and this frame appeared. I thought I would get a whistle this size, but it was just a frame for the whistle. This was ready in 10 minutes. This was ready in an hour. 3 hours passed, and it was 29% ready. After 4.5 hours, it was already 52%. It was late, and I almost fell asleep, but I preferred to stay awake to wait for the printing to end. I read some dreadful stories about printers that were left unattended during the night. The printing is finished. It's 2 a.m. 8 hours passed since the start, 7.5 to be precise. The whistle is ready. Please write in the comments what I should make with this printer. Maybe you'll have some useful and interesting ideas. The whistle is not very good. It cannot whistle loudly. I read some comments on it. People complained it didn't whistle loudly enough. If you enjoyed watching the video, click like and subscribe to my channel. There are lots of other interesting crafts. See you!